Excellent. All right. Well, thank you everybody for coming. I really do appreciate you coming here at the end of the day on Halloween, especially since you could be out trick-or-treating or doing something really exciting like that. My name is Pete Brown, and I'm going to talk to you today about desktop development and primarily about working with WPF 4.5. So we're going to look at some of the changes that have come about since WPF 4, and then we're also going to look at some of the new features in WPF 4.5, as well as I think some of the things that are good opportunities now with Windows 8. So why is WPF still relevant here, and why are you guys interested in WPF? So WPF was one of the first XAML platforms, and it has really great support for building desktop apps. It was also one of our first platforms that had really good touch support. So it's something that you can build touch-oriented apps building WPF with WPF today. And so far, I mean, we haven't had a huge explosion of touchscreen devices like in the past. We've had some touchscreen devices going all the way back to Windows XP Tablet Edition and whatnot, but we just didn't really have the proliferation of those devices out there. But now with Windows 8, we're starting to see, especially if you looked at all of those devices downstairs here in 92, we're starting to see a lot more hybrid devices where it's a Core i7 Ultrabook, but it also has a touch screen, or it's an x86 based tablet, or hey, here's like the stuff that Jordan was playing up on the stage yesterday, where you had the large Lenovo and being able to build touchscreens apps for that as well. So I think touch especially is going to become a much bigger part of our lives here going forward. Not just for building WinRT-based apps and Windows Store apps, but also on the desktop side. Because if those devices are out there, you're going to want to take advantage of that. One of the partners that I've been working with is a company who builds music applications, and they're building something which allows you to perform and has touch sliders and all that kind of stuff on it. And they have a lot of existing code that's in C++. They have they use a lot of APIs which are potentially unsafe APIs. They're loading virtual instruments at runtime and doing all sorts of interesting things like that. So they've taken their code and they ported it over to work with WPF and with touch and to make a better impression on Windows 8 devices. So now when you go to the desktop on Windows 8, if you use their app, it's fully touch enabled, and they're able to do all the things that you would expect on a touchscreen device, even though it's still on the desktop. Right? So I think those types of things are really big opportunities for us here with WPF 4.5 as well as with Windows 8. So how many of you have to integrate kind of mixed code? You have like Windows Forms stuff or C++ stuff that you need to pull in with your existing apps? Right? Excellent. So I think that's also another place where WPF really works well, where you're able to pull in some existing WPF code, of course, as well as Windows Forms code, C++ code, et cetera, where those types of scenarios where you have kind of this odd, messy integration of different chunks of application logic and application features, just there really is not another platform that does that as well as WPF. Right? So, and of course, how many of you need to support Windows 7 still for your apps? And that's what I figured. So, okay. So if you want to build apps today that still support Windows 7, then of course you're going to have to look at desktop apps there. Now, there are some scenarios we're going to talk about here that enable you to share code between modern store apps as well as desktop apps too, which I think will apply here. But certainly if your customers are on Windows 7, then you're targeting the desktop. So what are the choices for building desktop development today? Just the ones currently supported by Visual Studio here, console apps aside, as I had mentioned earlier. So WPF and .NET, of course, that's one of my favorite technologies. I've been a huge fan of WPF since day one. Windows Forms and .NET, again, same kind of code base behind that, just different UI layer on there, XAML versus the markup in code itself. C++ and Win32, I know a number of you in here are building native code applications, which is really great. Again, you can integrate that stuff in with WPF. And of course, Silverlight, I know a lot of you in here are Silverlight developers as well. So really the four of those, I would say, are the main desktop development technologies for Windows 7, Windows 8, et cetera, going forward here. And all of those are supported out of the box by Visual Studio 2012. So in Windows 8, we've added a number of new Win32 and COM desktop APIs. So certainly we've added a lot of stuff with WinRT, and we've spent a lot of time talking about WinRT at this event, as well as a lot of support for the new store model and whatnot. But we have actually made changes on the desktop side and added not just new APIs for integration with WinRT, but also just new APIs as an enhancement to the operating system, just as you would expect us to do in any new version of the OS. And of course, if any of you have been running Windows 8, especially on a multi-screen system, are any of you doing that as developers? You'll notice there are improvements for multi-screen applications in Windows 8. Especially, the simplest and easiest thing to see is the taskbar can now span across all the screens. You have more room there and stuff. And then the ability to use multiple screens is just considered far more normal than it was just a few years ago, right? So we have added a lot of features along those lines. And then, of course, we do have features here as well for integration with the new store model. So, for example, if you want to integrate with the packaging and deployment system for Windows Store apps, something like Visual Studio would do that, right? There are new APIs to do that as well. There's also things like new compression APIs, and then a number of DirectX APIs, which I know WPF developers have been using in their apps, especially the X Audio stuff when they're doing these kind of hybrid apps that also have to have real-time audio and real-time sound. Now, this is the API list. This didn't go over well when I submitted my deck. They really wanted to reformat this to 24-point, but that would have left a deck a mile long. But the thing is, all right, so here's page 2. And here's page 3. So as you can see, we have a number of new desktop APIs. And can anybody tell me what this one is right here? No, all right, I didn't think so. So that's great for a desktop. I know as desktop developers, we're used to having to pull in native API calls and Win32 and COM and stuff like that. But also, what's new in WPF 4.5? That's really what I want to talk to you about today. So understand that we have a lot of new features in the operating system itself, and then above and beyond that, we have a lot of new stuff that's directly in WPF 4.5. So the items in purple here are ones that are part of .NET in general, and there are lots of other .NET improvements, so I've just kind of scoped these to ones I think will be particularly interesting to you. And then the ones in green, such as the built-in ribbon window and ribbon, data binding delay, static property change, weak references, et cetera, are all WPF-specific enhancements that we have put in on 4.5. Now, how did we come about with this list of features? These were ones that our ISVs, as well as user voice and other places, have all requested. So a lot of these are features that folks perhaps in this room have submitted to us and said, hey, we really want the next version of WPF to do X, Y, and Z, right? The list here, though, is a list of targeted updates. So again, specifically trying to unblock these certain scenarios. And like great example of that we'll see sort of towards the end here is like live shaping of collections as well as some of the virtualization stuff. So we really wanted to make sure that as application developers, you're able to continue moving forward with WPF. All right. So let's talk a little bit about one of my favorite features in .NET in general, which is multi-targeting. So I know a number of you from talking to you prior to the start of this are building apps which have to span either Silverlight and WPF or WPF and Windows Store apps, or maybe you're also sharing code with websites, right? So I think that's a kind of a common scenario for many folks here. So what are the different ways and different uses for multi-targeting in your apps? So one of the things I think is easiest to look at is if you just scope yourself just as the XAML ecosystem, there are a number of things that you might want to share in your apps across those different platforms. So a view model is a really common thing to want to share across those. I mean, the whole promise of MVVM was go ahead and build your logic and build your view model, do it once, and the UI layer doesn't really matter, right? Right? Yeah, okay. I wink knowingly, yes. So for the most part, though, if you really kind of go nuts and do MVVM, we have really solid separation there. That actually works. I mean, there are a lot of people who are able to build apps that have that nice separation in there. So being able to share your view model across, say, a Silverlight app and a .NET desktop app, and maybe even a Windows Phone app or a Windows Store app or something like that, is a very valid scenario. And I think it's something that a lot of people really do want to do. Now, if you want to do server-side code, right? So I recognize a few folks in here who may have built a web app or two. And so if you want to be able to share your code, like your model and your logic and stuff like that with a server-side app, we have enabled that as well. And it's something that I think is very useful for apps that span multiple tiers, and you have to, say, share a customer object on the server and also a customer object on the client and be able to not do that, not create those multiple times. So there are two main approaches here. For folks that know me, I've always been a big fan of conditional compilation. I think it was, as ugly as it makes your code, it's the most flexible solution for doing multi-targeting. So in a conditional compilation, you have compiler statements where if Silverlight do this, if WPF do this, if it's a different version of .NET, then you have different parts in there. And that's something that you can use to abstract away namespace differences and a bunch of other stuff in your code, right? But also we have portable class libraries. And portable class libraries started off very simple as just a way to share some really basic model type code between the different layers in your applications. But it has really expanded to be a great way to share stuff all the way up to like, at an MVVM level where you're able to share your view models and, all your collection information and a bunch of other stuff across multiple platforms. So not just, say, like Silverlight and WPF, but also, again, Windows Store apps and even stuff like on the Xbox. Right. So when you're working with conditional compilation, I'm sure a few of you have seen code like this at one point or another. This is very simply, you just abstract away that namespace difference, or if you really have some logic which must be different for one platform or the other, then you're going to use this approach. Now, I actually use this quite a bit when I'm calling server-side objects and I want to share the definition between, say, a WCF service or something as well as on the client, where a lot of times I will conditional compile out all of the additional stuff that XAML requires, for iNotify property change and a bunch of other fun things that we all known to, or have all grown to love, right? So those different things there are really great candidates for using conditional compilation. And incidentally, if you want to do conditional compilation with WinRT apps, by default it defines NetFX core so that you're able to use that inside your code and count on that being there. Oh, and I have an article on MSDN Magazine from September. So if you're interested in that, I talk a little bit more about this approach in there. Now, portable class libraries, as I have mentioned, have really kind of come up in the world. This is something that is core to what the .NET team is doing. It is supported, and it is an essential part of their strategy for being able to integrate different types of technologies, enable you to write as little code as possible to target as many platforms as possible. So every time I look at PCL, they get more and more features added in and more capabilities. So currently, this is kind of a short list of those. So there are a bunch more. And I even left off the Xbox side of this here, but you can see that all online in MSDN. If you look at, say, like Link or WCF, all those things are pieces that you can share across these different environments. The MVVM support, which is really important, I think, to you all in here, includes stuff like iNotify property change and observable collection and things that we just simply couldn't share well before because there were namespace differences or there were differences in which library it had actually existed in. So all that stuff is now supported by portable class libraries. And I'll show you an example of this very shortly, but creating a portable class library is really easy. You go in, you create a DLL like you normally would, you use the portable class library template, and then you can add a reference to it from any of the supported projects. And it's really that easy. Now, it's not going to work for everything for you, which is why you can always use conditional compilation for stuff that falls outside of what PCL will provide to you. Now, Visual Studio 2012 does have built into it the PCL template. So you can just say file new portable class library, and then you can use that in your apps. So let's do a little bit here. So I'm going to just, good, there we go. I'm going to create a new app here just to show this. So I'm going to say new WPF application. That's good. And then I'm also going to add to this solution a portable class library project, just so I can show you what this looks like. So if I go down here under Windows, here is my, here we go, portable class library. And I gave it the original name of portable class library 1. And then when you're you are then prompted as to which versions of the framework that you're going to support. So you can, for example, support all the way down to 4, 403, et cetera. The higher levels of framework that you support, the more features you get available to you. You saw on that little chart that I had here, some things were .NET 4.5 and above only. So if you can limit yourself to that, you'll get the broadest set of features. So this is actually a really good reason for synchronizing your versions of the .NET framework across your different projects. So if you have server-side apps in your company and you're using those services and you want to really share code, and you're also creating WPF 4.5 clients for some of that, then you really want to try and get everybody on 4.5 if at all possible. And I know that can sometimes be a tall order, but I think it will make everybody's lives easier in terms of sharing and support and et cetera. All right? And then, of course, Xbox, which is cool. How many of you are building Xbox apps? A lot of ones. Crickets. OK. And then I think something else here that is often overlooked, and presumably this has also been covered in some of the other sessions that we have here, but when you're building a XAML app for the Windows Store, it is using a version of .NET 4.5, right? It's using a subset of the available .NET 4.5 space. It's not restricted to just WinRT. It's WinRT plus .NET 4.5. So for those reasons, you can then go and create a portable class library project that you can also use against Windows Store apps. Okay? So let's leave this. And of course, we have Silverlight 4 or Silverlight 5 and up, so that's good too. All right. So, and then if you look at this, it's just like any other class library. I can go in and I can change the name of that. I can say, this is my foo class. Yes, I want to do that. And then I can implement notify property. I can't spell. Is that an interface? I can't spell. Notify property change. There we go. I can implement that interface or resolve it first. Let's get down here. There we go. I'm actually better with a mouse than you would think, so all right. So this is something that, again, is not something that's been enabled for very long, so I think this is a big deal to be able to have that, and also be able to say, let's see, public observable collection string call, right, and then resolve that as well. So those are all allowed inside your portable class library projects. So if you have INPC support and you have observable collection, for the most part, that handles most of the things that you would want to do in a view model. If your view model is doing a lot more other stuff that you can't share, you might want to consider factoring that code out into what's called a service class. Not a remote service, but it's a local class that has functions that it provides to the rest of the app. And by having that separated out in your project and separate that out across the different environments that you're working in, it's going to make it easier for you to share that. So let me show this in action. I actually have a pre-baked example here, right? So in the best Betty Crocker example. So here's my WPF app. And I have in here a reference to this awesome VM, which is my view model. And my awesome VM up here is a portable class library project. So if we go, oh, here it is, reusable stuff, awesome VM. And inside this, I have just an example of using an observable collection. I happen to use string here. Of course, all the normal things you do with an observable collection are supported. Then I have notify property change on things like title. I'm exposing the observable collection just like we would do on a normal app. And then I'm able to use this. So let's use this from WPF. Start this. So here it is in WPF, right? So I have a list box here with the items all bound to it. Then if I go over to the Silverlight app here, you'll see it's the same kind of code back here where I'm just creating a new instance of that awesome view model. And the XAML across these is almost identical as well, where I'm just, in this case, using a stack panel and a list box. If I set this as startup, you'll see how that works. Right, so same data, same view model, same physical DLL. Right, so these are all using the same physical binary here. We're not having to separate that out or have those otherwise screwing up the rest of our file system. So then, of course, I can do a Windows Store app as well. Again, same code behind the scenes here, right? So I think that's something that's pretty nice. And then we have our super awesome app. So if you really want, here we go. So, so we share that with a console project as well. Okay? I'm not actually using data binding at this point. And if you want to look at the code there, again, same kind of thing. I create a new instance of that view model, and then I'm just iterating through there and just reading the items off. Okay? So that's really one of my favorite new things that's expanded with Visual Studio 2012 and .NET 4.5 is this really great ability to share these binary versions of these libraries across the different projects that you're working on. And I think immediately most of you folks will see the gain from that in sharing between your client and your server. Because I imagine many of you are building apps that connect to services and whatnot on the server. And at least from my experience in working with people, more often than not, you own both ends of that equation, or you at least know the dude who owns the other end of the equation, and you're able to share some stuff with them. And then, of course, with Windows 8, being able to build a WPF application that runs on the desktop and then provide some of that functionality as appropriate on the Windows Store side, sharing the same binaries and stuff, I think is a really big deal as well. It'll enable you all in your companies to kind of move and experiment with Windows 8 and experiment with Windows Store apps and see what's appropriate for you while still supporting your desktop apps. Okay? All right. So another feature that I really like that's in .NET 4.5, and we talk about this again a lot in terms of what's in Windows 8, but it's really enabled in .NET 4.5 as well, is async and await support. Do you all know what that is? All right, good, I'll skip over it, right? No. So how many of you have ever written asynchronous code before? Yeah, so how many of you have done it not because you had to, but because you wanted to? Yeah, you guys, so make note of those folks. Those are like the future serial killers and stuff in the room here. So I've written asynchronous code before. And if you're just doing a single call, it's actually pretty easy, right? So if you want to just say, get a call back, you make a single web service call, you get a call back, and you handle some stuff inside there. I think that's pretty simple. What gets really messy is if you have a call. Let's say you need to go and get a token from the server. You need to figure out who's logged in. You're going to get some token back, right? So you make this call. It's asynchronous. You get a token back. And then you need to make another call based upon that token. Maybe you need to pass it into another call, right? So now you have this sort of chaining where you have call B depends upon call A. When you've got that kind of situation, suddenly now you're setting up another callback inside the first callback. And how many of you have ever given that task to like the newbie programmers in your office? It's sort of like, hey, go debug this, right? And it's like, how many breakpoints can you possibly set in your code at once? So that really does, once you move beyond like 1 or 2 levels, it's absolutely crazy. It's not something I think anybody really wants to do. And because of that, there are a lot of WPF apps that do things like make network calls on the UI thread. Right? So you're sitting there and the app sort of like frosts over and you don't know what's going on. Early Twitter clients just did this left and right where they just figured Twitter would always be up and running and then latency would be pretty low, so they just did the calls from the UI thread, and then Twitter suddenly had millions of users and like one Commodore 64 serving up all the data in the back room somewhere. And they realized they really needed to do something to support that better. So, and again, it's just asynchronous was always hard. So now with .NET 4.5 and latest version of C# as well as the latest version of Visual Basic, you're able to use async and await. And the way that these work is really quite interesting. They are a compile time feature where if you mark your method with the async keyword, that tells the compiler that, hey, you need to generate an async aware version of this method. And what it does is if you use await, there's a little bit of checking. If you mark it as async and don't use await in there, it's not really going to do anything. But if you mark it as async and then use the await keyword in 1 or more spots, it's going to take all the local variables and state from that method. It's going to pull them out. And this is all compile time, remember. This isn't like magic generated code. It's all done by the .NET compiler. It pulls those all out and sticks them into a state class. Right? So, and that state class is then called from the new version of your method, which suddenly just becomes a great big state machine. And what happens is each time it hits an await segment. It's going to check to see, it's going to go make that asynchronous call, and it's going to return control back to the operating system or the rest of the runtime, excuse me. And then that runtime is then going to check, once it gets that callback back, it's going to check to see where do I have to execute next. And it's really just a counter. It's like a big switch statement at the beginning of the method that says, 1, 2, 3, 4, and it's going to check which step it's in. And in that way, it's able to maintain its position inside the method and give you this asynchronous capability without you having to write all this nasty code. So I think it's actually quite amazing. On my blog somewhere, sorry, that wasn't a shameless plug, but at the bottom here I have a link async state machine where I went and pulled up ILDASM just to see what was being generated behind the scenes. And it's very interesting to look and see what's being created as part of this. This is not an insignificant amount of code, an insignificant change to your code, but it works really well. So let me show you an example of that in just a second. Also, one of the new things that's in Visual Studio 2012 is the ability to generate these async methods as part of your add service reference. So before, you only had the choice to be able to do the callback and event type stuff. But now you can use task-based operations, which is what async and await are relying upon, being able to use task of T. All right, so let's get over to that. Excellent. So that's twice I've switched screens and it's worked, so I'm pretty psyched. So let me go over to this same app here and get rid of that PCL stuff. And so I have a website in this project. And this website, and it just has this async client on here, right? So, excuse me, it has an async service. So where is it? Oh, there it goes. So it's a WCF service. And actually, I use the Silverlight-enabled WCF service template because that's my favorite one. It's like really simple to use and stuff. And of course, you don't have to limit yourself to Silverlight in that. And so this is a service that's just going to run on the website there. It has a single method, get title, and it's going to return back build 2012, right? And now on the client, I have let me remove this and add it for you so you can see how that works. All right? So I'm going to add a service reference and discover here. So here's my simple service, and I'm just going to call the reference services. And if I go into advanced, by default, you're getting the task-based operations because you're working with .NET 4.5 and WPF 4.5. If I did not want to use task-based operations, I would change this to generate asynchronous operations. That's sort of like the masochist button there. So I mean, definitely stick with task-based operations if you can. Oh, and I'm interesting. Where's my? Let's see if enter works on here. Oh, here we go. Let's see. That is not the best sized dialogue I have ever worked with. All righty. Yeah, but I did delete that service reference, so let's see. Oh, actually, you know what? I don't need to. Here we go. All right. If anybody wants to talk to the team on that one, I think we'll do that. I mean, because so many of you are running Visual Studio at 1366 by 768, right? All right. Okay. Unplanned. All right, so now I have my service reference in here, and then if I go into my code behind, to be able to use that service reference, I create the client just like I normally would for any other regular service. But then if you look here, I've got this title text.text equals await client.getTitles async. That's all I had to do for asynchronous code in this case. So when this operates, when this runs, it's going to wait until getTitleAsync is executed before it returns the result of that back into this text box. And then after that is all completed, after that line of code is completed, then I'll get my message box in there. And you might think like, wow, Pete, you understand how like linear programming and stuff works. But understand that this is asynchronous. Like it really is asynchronous. It's returning control back so you don't frost over the UI or anything, even though it looks just like normal synchronous code. And by the way, there is a fair bit of stuff server-side that's also using the same pattern where people working in ASP.NET are able to make asynchronous calls doing the same thing. So let me set this as startup so you can see this. Let me run it. And you see that it waited until after I displayed build 2012, and then that method completed. So let me put a breakpoint there and show it to you one more time. And this seems like such a simple feature, but you imagine there's quite a bit of work that went into this, and it really is something that I think is, oops, where's my breakpoint? There we go. OK, that was bizarre. All right, so go into the main window loaded. And if I hit F10, it's going to create that client. Then I call get title async. And then message box show. So that is so very much easier than stepping through all those callbacks or event handlers or any other way that we've done it before. So I'm a huge fan of that as well. OK, let's stop that. All righty. So another feature that was requested, and of course the async and await stuff was just as much a requirement of the work that we've done with Windows 8 and WinRT as anything. If you've messed around with any WinRT calls, you understand that those are mostly asynchronous. Like most of the calls that you make in WinRT are asynchronous calls, like things like file I/O and even like really basic stuff. If it could take more than a certain number of milliseconds, they decided to just go ahead and make it asynchronous to make sure the UI was always very slick and very responsive. So this is another feature that was specifically requested by you all. And this is the ability to bind to static properties. And I always hesitate to show this feature, because if you're like a noob, you're going to end up doing this a lot. And then everybody else is going to be trying to figure out why you have like these massive memory leaks in your app and stuff like that. But it is something that unblocked a lot of our customers from some specific scenarios where they had to be able to bind to some static properties. Now, the downside to binding to something which is static is it's static. It's going to be around all the time. And if you don't have your references cleaned up and other stuff, then you could potentially keep your UI around for a lot longer than you want to. So you just need to make sure that you're being clean about your code and that you're properly managing the lifetime of other objects and whatnot in your application. But in this case, what it enables you to do, if you have, say, like a static settings class or something like that in your app, you can then bind to properties on that using this kind of funky new syntax where it's parentheses, namespace, so like local, for example, and then the class.property name. And the syntax had to be a little different here because you don't have an instance to bind to. You are binding to a property on a type, not a property on an object, right? And now we also support change notification for that, but you don't need to implement iNotify property change because there is no instance to implement that interface. Again, we're dealing with just a static class. So instead, what you do is you follow the same pattern. You just don't have the interface in there. So you have a public static event, property change event args, and then static property changed. OK? Everybody with me? Good? All right. So let me show you another example of that. So inside this class, I have this, or in this project, I have this app information class. And, oh, sorry, thank you. I knew I would do it once. Wow, through the magic of technology. Here we go. So I have this static class called app information. And this app information here has an event handler, or excuse me, an event called static property change, following the pattern that we just did. And then it has a single property title. And this property simply returns back this value foo in this case, right? And it raises the static property changed event when the title changes. So this looks, except for the name static and the static on the individual properties, it looks just like the kind of code that you would write for normal property changed. Okay, so everything that you could do there, same type of thing here. Now inside my code, or inside my markup, excuse me, if I want to do that, so I have a text box and a text block. And the text box here is binding, local is a namespace that's mapped to this app, to its root namespace. App information.title, that's the class name and the property name. I can use two-way binding, and I can also use things like update source triggers and stuff, again, all the normal things that we would expect to be able to use. And then I have a text block down here at the bottom, which also binds to the same thing, so you can see what I'm typing and verify that that actually is working. I know a lot of you are like, what's with the blue squigglies there or something like that? And the answer is I'm not 100% sure why I'm getting blue squigglies there, but I am going to talk to the product team on that because I think it might be a slight mismatch with what the editor is showing versus what is actually supported in the runtime here. But trust me, it does work. So if I go hello, okay. It's a 90s all again. All right. Hello there, folks. All right. So again, I have the text box at the top, bound to that static property, and then I have a text block at the bottom that's also bound to that in one-way binding. Okay. So really great stuff there. And again, it's mostly about one-time things like app settings and stuff like that. Again, I really encourage you not to. So I guess I discourage you from doing things where the static class that you're going to bind to is really fat. I mean, you don't necessarily want to have, again, a long lifetime for something that is like your data cache or something like that. Also, in those cases, you might want to consider singleton patterns and exposing that stuff, or IOC, especially if some of you folks are familiar with inversion control and dependency injection and stuff like that. Injecting those into your view model as either service classes or other stuff to get around some of these things. Just because there's going to be that one person on your team who's brand new and sees you binding to static in one place, and then like 3 months down the road you do a code review and every last class in the app is like static, and they're doing all the binding that way. So that's never going to happen, right? We also have new binding expression APIs. So I know some folks have been really interested in getting more runtime information from the binding expression. So we've also added in resolved source property name, target property. And this is really kind of debugging type information, but some of the people that were interested in this were building data-driven applications, and they're using some of this information to control how their binding system works and how their validation system works. So I think that's useful there. Now, another thing that I really like is binding delay. So if you consider something like a slider on the screen, right, and you know what's going on in the binding system behind that. Like if you use a slider for binding, every time you tweak that slider, you're getting a message sent across that's with a value change. And maybe that is linked to an object that's going to raise a property change notification on that class. So you potentially have this cascade of events that happens every single time that value changes. It's actually one of the big reasons why some folks think that binding doesn't perform really well is they don't realize how many things they actually have linked in that chain. Like it's doing some validation, and oh hey, this validation over here is doing a database query as part of my binding statement. So all those types of things can be happening, and you want to have some control over that. So you want to be able to decide. The database thing I've actually seen in code. I'm sorry, not my code, but somebody's code. And not at Microsoft, by the way. This was before I worked at Microsoft. So you want to be able to have some control over that. And one way that you can exert some control over that is to add something called a binding delay. And the way the delay works is if the value stays the same for the duration you have specified, then the binding events are fired and the binding system is updated and all that action happens. So if the user is sitting there like scratching like a DJ on their slider, you're not going to get 600,000 updates through the binding system. So let me show you an example of this. Let me make sure I don't have the... no, this is... I know I'll switch over here. All right, so in my main window, I have a stack panel. Inside that, I have a slider, right? And that slider is doing two-way binding with the value in a text box. So I'm just doing element binding between the two. And if I run this, so here we go, and you're going to, oops, here we are. So you see that all of those are bindings. I just made the guys that do the binding system cry when I do this. So here we go. Here you go, guys. There you are. And no smiley face, so I'm good, right? Or sad face, I guess it is. There we go. You haven't seen the blue sad face yet? There's actually an app you can get for that. It is just nothing but the blue sad face, which is kind of funny. All right, now if I want to change that, I can just say bind or delay equals 500. Okay. And you control that. It's in milliseconds, so I say 500 milliseconds, half a second. That is a ridiculously long delay. You probably don't want to go half a second, but it does make it easier to see. So I've got that value, and now if I keep changing, right, as long as I keep moving this, it's not going to update until I stop and let it rest for half a second, and then it updates. Okay? So I think that's really useful. It works with anything that does updates and binding. So one of the examples that was given to me, and I haven't tried this myself yet, but somebody was suggesting that it might be a good thing to use for if you want to do lookups from a text box. So the user's typing, and you have the text box set to update the source on property change. Well, while the user's typing, you might want to have them wait like 50 milliseconds or something like that between keystrokes, so then you can do the database query that pulls back results and populates the list box underneath it. Yes? So the question was, is the delay based on mouse up or when the slider stops? It's actually more fundamental than that. The delay is based upon when the value stops changing. So the binding system doesn't know what you did to change that value. It just knows that the value has started to stay the same, so it doesn't propagate that change through the rest of the system until that. Okay? So in this case, it's going to be when I stop sliding. Like if I can actually keep the mouse steady enough here while the button is still down. Yeah, so the button was still down there. Okay. Alrighty. And we just did those, so that's good. All right, so another nice feature here is list virtualization. So we've added list virtualization quite some time ago to WPF, but we didn't have the ability to really have better control over the display of those lists. So if you did list virtualization before, you couldn't deal with pixel-based scrolling. You only had whole elements because we actually did some clever swapping in and reusing of elements there. So now we support pixel-based scrolling. We support controlling the cache length, so you can say, I want 2 pages above and 2 pages below to be cached. And you can actually say 2, 2 for like before and after on that. It's a property there. And you can say whether or not you want to cache that number of items, that number of pages of items, and a page is based on what's actually displayed, or pixels, actually, if you want to cache a certain number of pixels. So we'll look at that in a second, I think, here. So the next thing is live shaping with the data grid. Do any of you deal with like stock ticker type apps where that kind of activity is coming through? Right, OK. So one of the things that folks like you have requested is the ability to be able to have sorted data in something like a data grid and have that updated in real time while being correctly sorted without like requiring a cray or something to run that, because that's actually a cray is not that powerful anymore, but I think you guys are. I'm dating myself on that one, I'm sure. So you don't want to have to have this massive amount of memory and everything used to be able to support that. It's just not practical. So the WPF team has put into the system here the ability to sort, and this is a data grid specific feature. It requires a data grid and it requires some views on the back end as well. They've added the ability in there to do this live sorting and live shaping of data, so it can also be grouping and have those update in real time without bringing your system to a crawl. In fact, it works really, really well, and it's orders of magnitude better than what we've had before in terms of performance. It does require a collection view. You have to set up sort and filter descriptions and whatnot. You have to tell it which fields to watch, et cetera. And so we'll take a look at that in just a second here. So let's look first at virtualization, because this is something that I think is pretty neat. So inside this WPF page here, I have this list. This list view. And I'm using the virtualization property, so it's virtualizing panel.scrollUnit, so it's an attached property to control this. And I can either scroll by item or by page or whatnot. So let's scroll by item. And this may not seem like a big deal until you actually start getting into the usability of this type of interface. So if I scroll by the item, I'm just going to use the arrow here. If these items are all very similar, your eye is not catching that the list is actually scrolling down, right? So from usability, it's actually poor to have this type of a UI, but you were willing to sacrifice that to get the reuse and the performance, because I've got, 6,000 items or whatever it is inside this list. You wouldn't want to do that without virtualization, right? A great example of this is if you've ever built a font drop-down inside your apps, you have to virtualize that just because of how long it takes to load that stuff up and load all those different fonts in there. All right, so now if I change this to pixel, and I'm going to still cache 2 pages before and after. And again, if I wanted to change it to like 3 pages after, I could do comma 3. All right. Now if I run this, and you see when I'm scrolling through here, now it looks like you're scrolling, right? but it's still virtualized. So this is something that's new here. This is not something that we were able to do before. And I think the experience of this scrolling versus the other scrolling is actually quite a bit better for the user, and immediately your eye understands that you're actually scrolling some content there. Okay. And then I also want to show you, let me pull up another app that I have here, that live shaping. So this is a simple app that I have that's actually using the new built-in ribbon. And you can tell from my awesome graphics up there that I didn't draw anything. I don't have a ton of artistic skills. And I have all my doctors over here on the left. And then if I want to load some data, so I've loaded, there's 300 items that are here. Now I want to update these in the background, and when I'm updating these in the background, I want this to stay sorted. So I'm going to keep updating, and you'll see that the values are changing over here in the data grid, and it's actually changing the sorting. In the list box on the left, those same values are changing, but the sort order does not change in that case because the list box doesn't support the sorting and the stuff that we need to do here. But I've got 300 items in this grid, and they're not all changing at once, so you might see some of them not change here for a couple of seconds. Oh, there we go. Something changed here at the bottom. Sell. OK. There we go. Let me show you what that looks like. So if I go into my data grid here. All right, so the data grid is a super complex data grid. There's no template or anything like that, and all I'm doing is I'm binding to this stocks view on my my view model. So then if I go to the view model and look up here, I've got my list collection view, the stocks view, right? And that is a view that's built on this observable collection, and I'll discuss some of this other stuff here in a second. Then down here, I am setting, let me put an enter on that. I'm setting some sort descriptions, and then I am adding those to the sort descriptions there. So again, normal stuff that you would have done with a collection view before, but now I'm also adding live sort properties, so it knows that it needs to check for live sorting capabilities on this value property that are in there, and then I am enabling live sorting. Okay, so those last two lines are really kind of the two key things that are making this magic work. Right. And that's really all you need to do to support that. And then the performance increase that you'll get in your apps is pretty immediate. Now, if you don't need this, there is obviously some code running back there, so there is a performance impact to running this. So if you don't need sorting, just don't use this feature. It's not necessarily something that you always want to have enabled if your app doesn't have sorting or anything like that in there. Okay? And let me switch back over. And collectively, we call that live data shaping. And again, it works with groups as well as sorts and other stuff. So it's pretty flexible. Okay? But again, it's a data grid only feature. I'm not sure if any of the third-party data grids support it, but Telerik and Infragistics and Component One, all those folks, I believe, are out there, so they'll be able to answer that on theirs. So next one is weak references. So how many of you, when you're building your apps, inside the shutdown code for your app, or shutdown code for a page, you're releasing all your event handlers? Yeah, you guys are liars. I know it. So this is actually a very common source of memory leaks in apps, is keeping these event handlers around, because everything works if you don't remove the event handler. And in fact, I'm terrible about this because I like to use Lambda expressions for event handlers a lot, and you're not releasing those because there's nothing for you to minus equals on that, because it's all an anonymous delegate, right? So we have had support for weak event references in WPF before. But we didn't have it really built in and made extensible in the system. So now we have weak event references built directly into WPF, as well as the ability for you to extend that system and add your own weak reference capabilities on top of that. The reason for that is the generic weak event manager is using reflection to look up these properties. So you're saying, I want to bind to this event, and you're providing a string that has that event name, and you're going to give it the method that you want to call. There's a very slight cost to that because you are doing a string lookup via reflection. If that cost is something that you can't afford to have inside your app, you can create your own strongly typed weak event manager, which knows about the classes on both ends of that, and you can derive your own version of that. Now, the way a weak event manager works is here's your source, here's what's giving you your event, and here's what you want to hook up to that event, right? The weak event manager sits in the middle, and it has the reference to the source of the event, and it also has the reference to the callback code that you have, the event handler over here. And then it is able to then release these more easily, because the old computer science thing that you can pretty much solve any problem with a level of indirection. Well, by having this level of indirection in here, you now have a place that you can remove that handler and remove that in there. And I haven't actually done it yet, because I was just thinking it right now. I believe it also will work with things like anonymous delegates and stuff like that. So it could be pretty cool stuff. All right. So collection synchronization is another big deal. So how many of you use threading in your apps? All right, knowingly. So I assume many of you have background threads where you're going to do some data lookups and stuff along those lines. So if you want those background threads to populate, say, a collection in your view model, so that's a bit of a problem. You can't. You're going to get exceptions. The reason you get exceptions is not because you're populating your view model from these secondary threads. The reason you get an exception is because you have UI code which is bound to that view model, or bound to that collection on a view model, and the view model is trying to raise these property change events going back to the UI, and that's a code call that eventually is like a UI code call and a reference to UI elements from your code, right, that's running on this background thread. And that doesn't work. You're going to get an exception. In Silverlight, it was always a cross-thread exception, and in WPF, it's another thread that tells you don't have access to that, or the collection can't be updated from this background thread. So what the team has added in there is the ability to provide synchronization where the background thread is able to update this collection, and it's able to update it from this background thread because you have provided a synchronization object for it to work with to make sure that you own that for just the amount of time that it takes to do that update. So the way that works, if you look up here, if you look over here on my screen, there you go. If you look here, I've got the observable collection of stocks, right? And I create that. I also have this private object stocks lock. And that is going to be my lock that is used by collection synchronization. And I then simply, here we go, call this enable collection synchronization method. And there's actually an event that you can do this in where if you're using a view, if you're using a collection view on there, then there's actually an enlistment event when it goes to create the default view and whatnot, so you can put this synchronization code inside there instead of inside this constructor. But if I just call this enable collection synchronization, I provided the collection I want synchronized, and I provided the lock object, WPF will take care of the rest to make sure that this is synchronized. Now, if you don't like this, if this isn't sophisticated enough for you, you can actually provide a callback method that handles the synchronization and tells WPF when it can go in and update that collection. So again, very flexible there. This will work for 99% of the different things that you're doing. So let me comment this out. I love coding by commenting stuff out. There we go. And then if I run this and then try to load data from a background thread, it's not going to work. And I'm telling you that ahead of time because this is going to give you an error. Here we go. And I wanted you to know that I meant to do that. So it gives me this type of collection view does not support changes to its source collection from a thread different from the dispatcher thread. All right. In other words, you tried to update this from a background thread. You all have seen this before. Okay. So now if I simply enlist this collection and synchronization by uncommenting. There we go. And I'll show you the code that does the load here in just a second. If I go keep loading now it's doing all these loads from the background. Okay? So again, all that synchronization is happening for me. I simply provided that lock object. Okay? Now, another way that you could have done that, and it's really messy, is you would have had to have provided either synchronization context references or dispatcher calls inside the loop that is updating this collection. So if I go down and look at that code here, let's see. Oops, start adding. Oh, there it is. So this right here, you see the way I'm spinning off the background thread is I'm just calling this task.factory.startNew. So it's nice. All the task parallel library stuff is now in .NET 4.5 as well, because it's also required by async and await, so I like that. So this is spinning up a background thread and then looping through there, and it's adding a bunch of new items every 2 seconds, right? And if I wanted to make this work without collection synchronization, I would have to either inside add new items or around that while true or something like that there, I would have to add a dispatcher call. But of course, we're not going to put a thread.sleep inside a dispatcher call, right? Right? OK, there we go. Just checking. OK, and so we've seen that. We've seen that. We're good. All right, so here are a couple of recommendations, because people always ask me, why would I write WPF, or how do I choose between writing WPF or writing Windows 8 apps or something like that? So, of course, if you want to target the Windows Store and have an app that can actually be purchased through the Windows Store, then you're going to want to write something in WinRT. Probably for you folks, it would be WinRT XAML to build those Windows Store apps. Of course, understand that your desktop apps can be in the Windows Store. If you are registered as a business in the store. Individuals can't put desktop apps in the store. If you're registered as a business, and your app has gone through the certification process, it can be listed in the store. So, for example, the app that I told you about at the very beginning here, where the company is building a desktop app that's very highly touch-enabled, and they wanted to make sure that they can also target the Win 8 Pro devices and whatnot, their app will be listed in the store in the future as well, because they're a business and they're able to do that. Also, the touch APIs and really the ability to work with a lot of the new UI stuff is simply cleaner to work with in WinRT as opposed to working on WPF. You can do this in WPF, but WPF was not necessarily written from the ground up specifically to support these types of UI interactions. If you want to write down-level operating system targeting apps, so if you're working with Windows 7 or Windows Vista or something like that, then you want to use WPF. So a very important point to make as well, WPF 4.5 is supported as back as, I believe, Vista. Anybody have Vista? All right, so it's supported as far back as Windows 7, so that you're able to target any of those with WPF 4.5. If you still have that one holdout who is also like on a 1968 Chevy that's beat up, and they have XP at home, and that to sort of like go along with the trailer and everything else there, then certainly you can build in WPF 4 to be able to target that as well, right? But all the new stuff that we're doing here really works best on Windows 7 and Windows 8. And if you want to share code and binaries between Windows Store apps as well as WPF apps, I think that's a really good way. Not just to make the most of the code that you're doing, but also to enable your business to move forward and be able to support tablet-based applications. And a great example is sort of the field adjuster who goes out at the insurance company and they need to take accident information. And yes, you could write a WPF app for that, right? But you're going to get a lot more out of the battery and a lot more out of the display and everything like that if you write that as a WinRT XAML app, right? So being able to share the code between the two of those is also a really big deal. So thank you very much.